Okay, our next speaker is Felix Barquero, laboratory experiments for the assessment of the impact of solar irradiance on clogging of ISMAR basins.
Okay. Hi everyone, happy to be here. My name is Felix Barquero and I work for the Innovas project in the TU Dresden. And together with my colleagues, I want to present you the first results or the first stage of our experiments in the influence of solar radiation on the development of clogging in spreading basin. So just going very fast here in this part because we all know what MAR is, and trying to put it in small words would be that it's the artificial way to enhance the groundwater storage, and after that it's depending on which site and what use you want to have, agricultural use, drinking water, or just the restoration of your water table. Here I'm going to talk about clogging not in wells but in spreading basins, which are bigger infiltration ponds in which surface water, commonly river water, is put into this basin and it's flooded, and then it's the vado zone, as it's seen here, is used as an active layer, either for filtering the infiltrating water, or also acting like a space for organic matter decomposition. So the clogging is a key issue in many MAR operations because it's the one that's determining how much water is coming to the aquifer. So the higher the clogging, then the less water we are putting in our aquifer. And also if we wait the longer, then the harder will be to restore our conditions and start infiltrating again. So everyone knows that sunlight has somehow an effect in the development of clogging. Higher radiation makes also a higher growth of bacteria and algae growth. This also activates the growing of this biofilm, which parallel is also blocking the pores, and it's letting less water going through the pores to the aquifer. So, but the question is, and where we didn't see too much literature, is how is this effect specifically? How much radiation, like with an increase of so much radiation, we are talking about an increase of how much clogging. And we wanted to have our first step into this topic and see, okay, this is the general view, and then continue to a second phase, which is what I explained just here. So about the materials and methods, we built a big box. We separated this box in 4 chambers. In the left-hand side, this yellow represents solar radiation with all their components, visible light, UV radiation, and infrared radiation. Whereas in the right part, you can see this black chamber, which is representing the nighttime, no radiation, completely darkness. And then we were trying to have something in between these two, so we decided to pick up from the visible light the lower and the upper boundary, which could be representing to the cloudy days. So we have here 450 nanometers radiation wavelength, and here is 650. We were working with 24 columns of 50 centimeters each. They were filled with sandy sand. The K value is approximately 10 to the power of -5. And they were separated in 2 rows. The rows that's in behind was the row that was infiltrated with river water, specifically the Elbe River water that flows in through Dresden city. And in the front, we decided to have also like a background, and we did the same infiltration with tap water. In each chamber, we also use triplicates to avoid some outliers. And then here in the lower part, you can see that we had 2 reservoirs, one with tap water, the other one with river water. And first, we sent this water to the upper reservoir where the water was just by overflow, homogeneously flowing into each of the columns. Each column was working also with an overflow itself of 5 centimeters. The reason for this is that we wanted to assure that there was a constant flow in every one of the 24 columns that were running parallel. And when working, especially with river water and with column experiments, the hose is so small that it tends to be clogged. So, and this was supposed to run day and night, and so we wanted to avoid that there were so problems during the night. So here is a view of how I actually look like, so not that nice as in the sketch. So here we have the two tanks, river water and tap water. This was flowing to these upper buckets, which had the hoses in the lower part, and this was going to each one of the chambers. So as I mentioned before, we were running the columns with a constant head of 5 centimeters, and we were continuously infiltrating day and night during 4 weeks. After these 4 weeks, we said, okay, we assume now the basin is completely clogged. We need to perform some anti-clogging measures, like some maintenance measure, and we did some scrapping. And then we resumed the infiltration. So for determining the reduction of the hydraulic conductivity, we performed tracer tests in which we had the linear velocity that the water needed to go from the upper part to the outflow. We were using natrium chloride for this. We were also checking in the time the concentration of the total suspended solids in order to be sure that there was not after, for example, a rain event, the water is coming from the elbow with a turbid water, so we wanted to avoid this for our experiments. We were also controlling the DOC in the outflow to see if the radiation or the increase of the fouling layer, of the clogging layer, has an effect at the end in the removal of DOC. We were also controlling the temperature. As you know, the radiation also is hand in hand with temperature, and we wanted to control this. And at the end, each of the columns we separated in 4 layers, and we sent them to a chemical analysis of total organic carbon to know in which part of the column we were having most of the organic content, which is representing also the biomass. So here is a view of the columns without the box. Here you can see the tap water row, and here is the one for the Elbe River water. We rubbed all of them with aluminum foil. The column is transparent, and we didn't want that the radiation was also inciding the lower part of the soil. So the radiation should also only come from the upper part. So this is how it would look at the beginning, and after infiltration, you can see that here it looks a little bit turbid. If we go a little bit closer, it's looking like this. And here, it's not that nice to see in here, but in the photo, you can see maybe a small darker line over here. This is the fouling layer that was between 1 and 2 centimeters. So about the results, I will talk to them in 3 stages. First, the tracer, then the scrapping, and finally, the outflow results. Here we can see the results of the tracer experiments in each one of the columns for sunlight, blue light, red light in the darkness scenario. The green dotted line represents only the 4 weeks that we gave. After the 4 weeks, we perform a scrapping event. And the shape of the curves can be related also to the curve of the bacterial growth, in which we have first initial or lag phase where the bacteria is just starting to assimilate the conditions. There's food, there is oxygen, so they start to reproduce. And we could see this phase in every one of the columns. Then, after 5 days, it starts the growing phase of the bacteria, which for us was an exponential decrease of the infiltration rate. And it comes afterwards to a stationary phase where there is not that much change of the infiltration rate. Analyzing furtherly this data can be a little bit tricky because it's a lot of points and a lot of lines. So we did a mean, an average of each one of them, and we got to this summary graph where there is actually not that big difference to be seen, especially in the black line, darkness, and the yellow line, which is radiation. At the end, it was representing a little bit more than 10% difference. So, but still, and between the blue line and the red line, there was not a significant change. Looking now in the scrapping event, that means after the 4 weeks, so ignore this first part, we can see that there was a recovery of the infiltration rate, but nevertheless, this recovery wasn't that high. In the case of the darkness scenario, it recovered a little bit higher than 50%. And then it was faster. This progress that we had here for 5 days, it here needed like 1 or 2 days to start going down. Thank you. So now talking about the outflow rate, in each of the columns, we also did the average of the how fast was the water flowing out in the columns. And here was more evident the change between the darkness scenario and the scenarios with light, where the difference was approximately 30%. Now talking about the TOC, we have here the 4 scenarios, and here we have the 4 layers that we divided. And as it is expected, because of this fouling layer in the upper part, we have always more than 90% or more than 85% in the upper part. But what can also be seen here to make valid the hypothesis that in darkness we have less biological clogging than in the sunlight scenarios, it's looking at this value as 2.7 against the one of 6.5. So going shortly with the conclusions, we can state that indeed there is a change of the clogging depending on the radiation that we are having in this sequence. First is solar radiation, then blue and red radiation, which didn't have so much difference, and then the darkness radiation, the darkness scenario, where the difference was, according to the outflow rates, about 30% less clogging. And this is representing also the night scenarios. So here comes the question if it would make sense to make hydraulic loading cycles while flooding the basins during the night, early morning and early afternoon, and then letting the basin dry during the mid of the day. I just want to stress out also that when I was talking about clogging now, because this was the first stage, we are talking about a mixture of biological and physical clogging together, because we wanted first to have an idea how it's developing. So in the second stage, we are planning to have our artificial physical clogging water and biological water to see what's the difference between these two types of clogging. And lastly, that the clogging was observed in the upper 5 centimeters. Thank you very much. Is there any questions?
Great. Thanks very much, Felix, for a great talk. Any questions for Felix? I have one then. You mentioned in the start of the talk that one of the key processes when dealing with the surface water is both microbiological and algae. Did you look at the algae concentrations between the 4 light sources?
That was the plan at the beginning, but unfortunately we didn't have the chance to work with the microbiological lab to send them the samples. So for this second stage, we want to have indeed the bacterial characterization in each of the stages of the experiment.
Okay. Peter?
Was there a significant difference in temperatures?
There was not.
Between the 4?
There was not. I was not expecting this. The 4 chambers, they were isolated from each other. We used different materials to assure that there was not an influence between chambers and chambers, but the temperature was constant in all of them.
And equal to?
Equal, yeah.
Okay. Any other questions for Felix? One down the back.
Thank you very much for your presentation. As you told at the beginning, this experiment is aimed to kind of define or represent surface infiltration bonds using this column experiment. And as intended for this final aim of the experiment, have you thought about any kind of reactor or bigger experiment and setting different depths of water affecting this sunlight radiation? Not only because the sunlight would fate on the depth, but maybe the different biological communities would happen there during different resident times or different conditions. Have you thought about this kind of future experiments?
Yes. As I said at the beginning, we want just to explore first the field, and that's why we decided to work with columns, because they are easy to work with and they don't require too much volume because we were infiltrating day and night for one month. This was a huge amount of water, what we needed. That's why we decided to have smaller columns. Now I would say that yes, we would go for a bigger infiltration unit, because now we also know, okay, that it doesn't too much difference to work with this blue light and red light. We would focus more in the darkness and the solar radiation scenarios. But for sure, we are going to go with a bigger unit.
Because in the case of the difference of solar radiation, it would mean that you make it because there is some parameter that would change. I mean, solar radiation changes not because of nothing. Maybe it's like the latitude or the different depths of the water. So maybe aiming in a further direction that relates the experiment to the reality. So that's what I'm saying about it. But thank you very much.
That was tip. Yeah.
Great. Thanks very much, Felix.